In the last getting started, we looked at the angles that were a 37-degree angle and a 53-degree angle. I bet you this is why. Check this. If you take that tracing paper from the last video, from page 590, and you push the 37-degree angle, it should pretty much fit into the corner of this 6, 8, 10 right triangle. All the way, I know it's a right triangle because 6 squared plus 8 squared is 100, and 10 squared is 100. And so that's kind of our check if the Pythagorean theorem is actually working in our favor. You take the two sides, legs they're called, take the two legs of the right triangle, square them and add them. Get an answer. Then you take the hypotenuse and you square the hypotenuse. And if those two numbers match, you have a right triangle. If they don't match, it's not right triangle. Maybe it's acute or maybe it's obtuse. It depends on the relationship. That's for a different lesson, this one. But right now, they match. It's a right triangle. Now, if I take my 37-degree angle, actually can confirm this is approximately a 37-degree angle. And by the complementary angle relationships in right triangles, this is the other. You see it right here? This angle in this corner is the other angle that's complementary to 37. So this one is approximately 53 degrees. I just want to acknowledge that carryover from the last page to this one. So with that, right, the idea being angle, I should answer question 4. Consider the triangle PKR. Explain how you know that angle P and angle R are complementary angles. Well, 1, I used the tracing paper from question 1 to fill out, to figure out that this was the approximate size of those two. But here's another way to justify it as well. When you add up all 3 angles in a triangle, all 3 angles should sum, S-U-M, to 180 degrees. But there's a box in the corner of the triangle at K, and that box, that little square, because it's a square, means that that angle K is, that's right. So we're going to do a little substitution, which means the measure of angle P plus the measure of angle R plus the measure of angle 90 is 180 degrees. Okay, we're back. So taking away 90 from both sides, right? Here's 90, here's 180, so take away 90, means that angle P plus angle R is 90. Measure of angle P plus measure of angle R is 90 degrees. And when two angles add up to 90 degrees, boom, roasted. They're complementary angles. Two angles are complementary when the sum of their angle measures equals 90. And so there it is, angle P and angle R, they have to add to 90, so therefore they're complementary. Write a ratio that represents the sine of angle P. Do you remember highlighting the opposite side? We're going to highlight consistently. Sine is the opposite over the hypotenuse. Sine, opposite over hypotenuse. Sine is opposite over hypotenuse. So we're going to write a sine ratio for angle P. That puts my reference angle here, and it lists 6 as the opposite side. I was going to highlight it yellow, but I'm reading question 6, and I'm seeing into the future for this lesson. So therefore, I can write sine of angle P this way. Opposite over hypotenuse. There it is. Oh, it reduces, by the way, 6 over 10. They're both even, so we could reduce it to 3 over 5. Okay. Question 6, write a ratio that represents cosine of R. Changes the reference angle. Why don't you do that? Pause, skip forward 30 seconds. Well, you're still here, so I'm going to write it out as well. Because angle R is the reference angle, that changes angle or side 6 to the adjacent. Cosine angle R equals 6 over 10. Did you notice that those ratios are equal? The sine of angle P and the cosine of the other angle R are the same. The ratios are the same. why does it make sense that those ratios are equal? If you're focused on angle P, and then you align up your hypotenuse, your opposite, and your adjacent side from angle P, and you get a sine ratio of 6/10. That's because you had to look at the side opposite from angle P. But if you change your reference angle to angle R, and so instead of being up at angle P, now you're over here at angle R, and you redefine your sides of the triangle, then the hypotenuse stays the same because it's always across from the 90-degree angle. But your adjacent side is now next to, it was the opposite side from angle P, but now it's the adjacent side to angle R. So the reference angle matters, and it changes the opposite and adjacent locations, which means that sine of angle P is actually equal to cosine of angle R. Cosine of angle P equals the sine of angle R for the exact same reasons. Cosine of P would be 8/10, and sine of R would be 8/10, all because we're talking about how it's adjacent hypotenuse, but it's to angle P, and now it's opposite to angle R. But the hypotenuse is still the same. That 8 is used in two different ways based upon the reference angle, but the hypotenuse is the same hypotenuse. It's still equal ratios. Okay, here's the big picture. Complementary relationships in right triangles where sine of one acute angle is equal to the cosine of the other acute angle. You can stop watching this lesson. Just solved it all for you. I'm kidding, don't do that. Stick around for the next page. Thank you for watching this episode, and I'll see you in the next page 592 episode.